Hey guys, this is a series where I attempt to do LeetCode problems, and these are problems that I've never seen before. I'm actually already slightly scared by this one. It has so many thumbs down, and this is going to be the first medium problem that I'm attempting. So most of the easy ones are relatively straightforward and there's no real issues. However, mediums tend to get a little bit more tricky, and there's a chance that I might not even be able to solve it, or when I do solve it, it's likely that I won't have the most optimal algorithm for the first attempt, and I'll have to iterate and try a few times before I get it. So regardless of the result, I'll upload the actual video so you can see. But just be aware that just because I'm uploading a video doesn't necessarily mean I found the optimal solution or that I even solved the problem. So let's get started. You have initial power P, an initial score of 0 points, and a bag of tokens. Cool, we got 3 things. Each token can be used at most once, has a value of token I, and has potentially 2 ways to use it. If we have at least token I power, we may play the token face up, losing token I power and gaining 1 point. If we have at least 1 point, we may play the token face down, gaining token I power and losing 1 point. Okay, return the largest number of points we can have after playing any number of tokens. Again, reading the problem statement like this isn't always very clear to me. Looking at the examples tends to help out a lot. So, okay, tokens, we have 100 tokens. P is 50, so initial power P, and then output would be 0. Okay, this is an amount of tokens. This is the value of the token, right? Yeah, value of token I. And then P is 50. So tokens here is 100, 200. P equals 150. So is it greater than or equal to? Each token can be used at most once. And has a value of token I, and has potentially 2 ways to use it. If we have at least token I power, we may play the token face up, losing token I power, gaining 1 point. So if we play the 100, we're down to 50 power. Is that how it works? Or we can play it face down and then we lose a point, but then we gain that power, so then this power increases. Interesting. Are the powers in sorted array or not? Let's see. We have token and a bag of tokens. It says nothing about the order, although it shows the potential length in all the notes here. Huh. So these very high value tokens, we're going to always want to play face down so we get more points. So in this example, if we play this face down, then we get 600. And then these, we can play all 3 of these tokens because it's 100, 200, 300. So we gained 3 points, we lost 2 points, and we end with P equals 0. So then it's a similar, well, not similar situation here, but for here, we actually don't want to play this face down at all. We actually don't even want to touch this. We only want to use the first token, and then we have a power of 50. Okay? And then here we have tokens equals 100, and we have P equals 50, so we don't actually want to do anything with this whatsoever. Huh. So what I'm thinking of doing is, well, for this problem, it's a little more straightforward, I feel. Because we essentially want to make P large enough to encompass as many things until we can't anymore. So for example, we have 200, and then 100 we can already do, so we want to do that instantly. So we want to sort the tokens no matter what, I believe. Let's just sort the tokens. So tokens.sort, I believe we're allowed to just modify the tokens and it should be fine. So a comma b, and then we're simply going to want to return a minus b, because sort by default is lexicographical order, and we just want it to be from smallest to largest, which is just this formula. So cool. So now we should have sorted tokens. So yeah, as I was saying before, 200, and then we would have 100, but then like we can't do this one. So if we can't do this one, we want to see if we're able to place this one face down in order to get this one. And if we can place this face down to get this one, we want to do it. So we know that we can in this case. So we will do it. And then we see if we can do this one, and we can, so then we have 2. Let's see if the same algorithm would work for the thing above. So we want to do this one, and we can, so we do it. And then we want to see if the last one is able to mortgage to play the last one, but that doesn't make sense since they're the same. Okay, so we want to see if we're able to play this one. We can't. So we want to see if we're able to mortgage this one to play this one, which doesn't make any sense. Okay. So for at least all of these cases, the general algorithm of going through them and deciding whether or not we want to mortgage the last one to be able to do a new one does seem to work. We just have to check to make sure that we're not trying to mortgage the same one that we're trying to use. So as long as those indexes are not equal, it should be fine. So let's go ahead and say let points equal 0, and then we can start iterating through. So what we want to do is for let I equal 0, I is less than tokens.length, and then we increment to I. And then here we're going to want to say if points is greater than or equal to tokens I, then we are going to want to go ahead and not points P. P is very different from points. Yeah, this is power. So if power is greater than or equal to tokens, then we want to say P minus equals tokens I. And then otherwise, what we want to do is we want to say if tokens.length minus 1 is not equal to I, because we want to make sure that those things are not equal to each other that we're checking. I'm not 100% sure about this, but we'll look at it in a second. So if tokens.length minus 1 is not equal I, and well, we're always going to be able to mortgage the last one for the one that we're looking at, right? Because the one that's last in the list will always be greater than the one that we're trying to do. So we always know that if we mortgage it, we'll be able to play it. So we can go ahead and do that automatically. So then we're just going to want to say P plus equals tokens tokens.length minus 1. And then we're going to want to say P minus equals tokens I, since we can still actually do this. And then we're just going to want to, no matter what, increase points by 1. Is that true? No, not necessarily. Only in these cases we want to increase points by 1. So points plus plus. And here we can also, well, actually, no, in this case, we don't actually increase points whatsoever, right? Because in this case, we're just using the large one and then getting rid of the small one. So P gets modified, but since we're adding one and subtracting, well, playing one face up and playing one face down, we don't actually change points at all. So, okay, only here we increment points. And then after we've gone through them all, we want to return points. And after we've added this one, we actually want to get rid of it from our array. So we want to say something like tokens.splice, tokens.length minus 1, and then 1. And then we return points. So let's go ahead and run the code and see what happens. So expected output is correct. So let's go ahead and try our next example, 100, 200. equals 150. We would expect this to be 1, but we're outputting 0. Why? Okay, so let's go through our tokens array, which is tokens.length L. Let's try just .length. Okay, so we get the proper result there. Let's go ahead and try that first problem again to see if it actually worked properly or if it was just because of the typo that it worked. Running okay, output expected, that all works. So let's go ahead and try the last example that they gave us and see if this one works properly. So this one should actually hit this portion of the code. Cool, so that looks like it works. So let me go ahead and make sure there's no off by 1 errors here. So if tokens.length minus 1 does not equal I, because we want to make sure that, for example, this is not equal to the one that we're looking to mortgage, we want to make sure that this is not the same as this, which as long as it's not the same as this, we can always do this. It might be useless in some cases because we might be getting rid of the 1 and adding the 1 right next to each other, but we can always do this and we know that the result will not be messed up whatsoever. Actually, could it be messed up? No, because we're still incrementing I. For a second I was worried because I thought that like, oh, we would still look at that one next here, but we actually don't look at that one next because we're still incrementing I, even though we're not incrementing points within this loop, if that makes sense. So cool, I think this works. The biggest issue is I don't know if it'll actually be fast enough. There could be a way to do this in O of n, but let's go ahead and see if this is accepted or not. So, okay, it looks like we have an incorrect answer somewhere. So if we have 71, 55, and 82, and then P is 54, what would we expect the answer to be? So this one, we would expect the answer to be 1, right? Expected 0? I'm confused. I thought we could get rid of this one, 82 plus 54. One second, I'm looking at calculator. So, in this case, we have 82 plus 54, which is 136, minus 55 equals minus 71, 10. So I thought we could get rid of 1 and then play these two and it would be successful. It looks like that's not the case. So I'm guessing I misunderstood the problem somewhere. Each between the largest number after playing any number of tokens. Do we have to play the tokens in order? I don't see anything about that in the problem. You have initial power of P, an initial score of 0 points, and a bag of tokens. Each token can be used at most once, and has a value of token I, and has potentially 2 ways to use it. If we use token I power, we may play the token face up, losing token I power, gaining 1 point. If we have at least 1 point, we may play the token face down, gaining token I power and losing 1 point. Return the largest number of tokens we can have after playing any number of tokens. So we can play it at most once. There's nothing that's said about the order, though. Okay. But for this code, let me make sure it actually is what I think it is. The output is 1, but it expects 0. So maybe even though the problem doesn't state it, it wants us to only do things in order. Huh. Okay, if we did it just in order, then what would happen? 71. So we have our 54 points, and then our 54 points. We cannot use this one, so we'd want to mortgage it, not mortgage it, play it face down, and then we would do that one. So I'm guessing either I have poor reading comprehension or we're supposed to only play these in order. So if we're supposed to only play them in order, then this becomes an entirely different problem. I know that I said that I would always. So what I'm going to do here actually is check the discussion and see if the problem is just misstated or to see if I'm wrong in some way. Because if I'm wrong in some way, then I just spend this whole time doing a problem that's useless. Let's go ahead, check. Bad descriptions. At first I thought losing points, not getting them. It turns out we can take whatever tokens that we want. At first I thought losing powers less points means not getting them, but it turns out to be minus the power point we got. Losing is not as clear as minus, a little misleading. Bad example 3, I didn't really consider because I thought we should take the token in order, but we can take whatever we want, which should really be emphasized. That's what I thought it was. The description didn't include the situation where power is less than tokens I and point is less than 1. So wait, we can take them in any order? Then I'm very confused about this, right? Because minus 1, plus 1, plus 1. Output should be 1. The description didn't include the situation where power is less than tokens I and point is less than 1. Okay, someone asked me to translate the problem description, so I have add my understanding here. Hope it helps. You have a bag of tokens from which you can take whichever token you want. And after you take one, you can't put it back into the bag, meaning you can use every token at most once. You start the game with P power and 0 point. For every tokens I, you can use it in either way. Plus tokens I power in minus 1 point, or minus tokens I power in plus 1 point. Meaning you exchange your powers to get 1 point or exchange your point to get more powers. But you have to make sure that during the process, uh, both your powers is greater than 0 and points is greater than 0. I see, I see. Because the issue is that in here, we can't actually go negative. That was my misunderstanding. Okay. Because we can't ever use any of these, and if we did use any of these, then we would have to go negative, which is not allowed. Which actually makes this problem a little more interesting, right? We can't always just take the, well, we always do want to take the largest one and mortgage the largest one if we can. So actually, if we just had here an extra check to make sure that we don't go below 0, so we can't actually, no, we don't want points to go below 0. So we just want to make sure if points is not equal to 0. Cool. So that solves that test case, so we can go ahead and submit again. And now we get the accepted answer. Okay. So yeah, here I had to go look at the discussion because I was confused. I wasn't aware that we can never have points go below 0. So where did it say that in the problem? Let's make sure I misread it. You have initial power of P and initial score of 0 points in a bag of tokens. Each token can be used at most once and go both ways. If we have at least token I power, we may play the token face up, gaining power and gaining 1 point. If we have at least 1 point, we may play the token face down. So yeah, this is a situation in which reading the problem very, very closely is very important. I missed the if we have at least 1 point, which made this problem very difficult and made me not realize that I made a mistake. So yeah, that's about it for this one. So this is another, before I end the video actually, this is a good example of even when like you're solving a problem, even if you're generally good at these types of things, you're still going to make mistakes like this. Like you're going to have a slight misinterpretation of the problem, and you won't always be able to get it super fast and super easily. Maybe there's some people that always can, but like these types of issues, you don't run into them too often, but they do come up, and it just shows that like uh, you can't be perfect at these types of things. So yeah, in an actual interview situation, the best thing to do would be, of course, to talk to the interviewer and explain your assumptions, and then your interviewer, if they were good, would quickly point out that you're making an incorrect assumption where you can have your points go below 0. So, yeah, that's about it. Thanks.